I'd like to focus in more on what that tau really means in the graph. And so the idea is, let's eliminate the k1 for a second here and just take k1 to be 0. So we have this k2 e to the negative t over tau. So the idea is it's going to decrease, and if I go 1 tau time period here, then it's going to turn out the y value is going to be at roughly 37% of the original amount. And if you go another time period, it's going to go 37% of that amount. And so what that happens is, if you are ending up at 37%, that means you're decreasing by 63%, or more accurately 63.2. And so the idea is, if you look at your graph and you pick any point in time here, call this a regular t, and you go over 1 time period, 1 tau, and you look at the y values here, then you're going to be able to see that you decreased at 63% of how much you started off. It's kind of an interesting way of looking at it. And so this particularly is going to be useful in the lab when you want to try to measure tau. You're going to look at your graph and you're going to try to figure out how long it takes to decrease by 63.2%, and that will then give you your time constant, tau.